Moving on to the next one, we have drift velocity and relaxation time. The drift velocity is indicating as a symbol of V suffix d, and relaxation time is defined with a symbol of tau. Okay. Now, moving on to this concept, let's take one copper wire. So, copper wire has 29 electrons in it. Sorry, copper atom has 29 electrons in it. So here arranging it, it becomes 2, 8, 2, 8, 18, 1. So this 1 is valency electrons. So here I draw the structure of the atom of copper. So here we have a nucleus, and these are all the electrons which is revolving around the nucleus, and here we have one valency electron. Suppose this valency electron is detached from this valency cell, and this is the main reason for conducting current, because this electron is detached from this valency cell and it becomes free electrons. So once we detach these electrons from this copper atom, what will happen? The sense this copper atom becomes copper ions. So Cu1 plus, because we remove one electron. So here free electron we have. So this free electron can move inside the material in anywhere, and it can move random direction. So similarly, we have considered only one copper atom. In that material consists of number of copper atoms. So similarly, we have so many copper ions here we have. So any one free electron can come closer to this copper ions, or this copper ions, or this copper ions, or this copper ions. Anywhere it can go when in the absence of electric field. Why it moves in the sense? Due to thermal energy and the movement of this velocity of free electron, we are saying that thermal velocity, and the average velocity of electron is 0. Why? In the sense, suppose if any free electron move in any direction, it is equal to the number of electrons which is in the opposite direction. Suppose two electrons are moving in the upward direction, in the sense two more electrons will go down in the downward direction. Therefore, it will cancel out, and the net average velocity becomes 0 when in the absence of electric field. For very good understanding, I do this small demonstration here. Let assume that this is one of the copper atoms which has one free electrons, right? Sorry, one valency electrons and one valency electrons it has. So right, so once if you remove this valency electron, it becomes free, right? It can move anywhere inside the metal or inside the anywhere in the conductor. Similarly, if you have more number of copper ions, okay, more number of copper ions, so it can either come here, or otherwise it can go here, or otherwise it can come here, or otherwise it can go anywhere else inside the conductor. And what will happen? The motion of this free electron is random. Anywhere else it can move, anywhere else. Yes, somewhere else it can move, right? So similarly, what will happen if apply the electric field? If we apply the electric field, then these free electrons are try to align the field of applied electric field. And when we apply the electric field, this free electron can move. When the absence of electric field, the electron can move randomly, right? Yes. And when we apply the electric field, actually the electrons are go in that line, okay, when in the absence of electric field. If you are applying the electric field, what will happen? The sense as in that this is the lattice, okay, so this is the lattice. So what will happen? The sense the electron will get, actually it goes in this line, right? Now it will slightly drifted in the, and it will go in the dotted lines, and it will hit the ions and will return back and align. They are trying to align in the opposite direction of applied electric field. Suppose if you are applying the electric field this direction, the sense all those electrons are aligned in opposite to the field directions. This is for one electron. Similarly, we will have more number of electrons. For that, I am given as when we in the presence of electric field U1 plus a tau 1. What is tau 1 in the sense? Relaxation time. So what is U1 in the sense? It has thermal velocity, and a tau acceleration into time, that will give velocity. That is the velocity of single electron. Similarly, here I consider the 4 copper ions. So I am taking as 4 different copper ions velocities here I note down. So U1 plus a tau plus U2 a tau plus U3 a tau 3 plus U4 a tau 4 whole divided by n. Here I have taken as n as 4. That is the average value. Then this gives about the drift velocity. The drift velocity is the average velocity is gained by the electron when we apply the electric field for that conductor. Now take U1 plus U2 plus U3 plus U4 divided by n, plus here we have a, here we have a, here, and take it as common. Tau 1 plus tau 2 plus tau 3 plus tau 4 whole divided by n. What is this tau? What is this tau in the sense? This is the collision time. So when collision time divided by number of average, that will give about relaxation time, right? So this will give the relaxation time. Therefore this factor becomes 0, because of, I said very clearly, in the absence of electric field, the net velocity becomes 0, right? And plus a into this factor is called as relaxation time, the average time taken, and Vd is equal to 0 plus a tau. This term is 0 and this term is a tau. Tau is equal to tau 1 plus tau 2 plus tau 3 divided by n, and we can write drift velocity Vd is equal to a tau, and we know that F is equal to ma. From that a is equal to F by m. So F is force. So a force can be written as charge into electric field divided by m. Substitute this a value here, then we can write drift velocity Vd is equal to E m divided by m into tau. That is the expression for drift velocity.